Hello everyone, welcome to the part 1 of the series of proving trigonometric identities. In this video, we are going to learn some proofs of some known trigonometric identities. Let's start with the most well-known identity, the Pythagorean theorem. So this is the Pythagorean theorem, sine squared x plus cosine squared x equals to 1. So imagine a right-angled triangle with adjacent length of x and the opposite length of y and a hypotenuse of 1. So we know that Pythagoras theorem states x squared plus y squared equals to h squared or hypotenuse squared. And if you square 1 by 1, it will be 1. It, so x squared plus y squared shall equal to 1. So we also know that sine x equals to opposite by hypotenuse, which is equal to x by 1 or only x. And we know cosine x is adjacent by hypotenuse, which is y by 1 or just y. So I've proven that sine x equals to x and cosine x equals to y. And if you multiply both sine x and cosine x, if we square them, we will get sine squared x equals to x squared and cosine squared x equals to y squared. So since sine squared x equals to x squared, you can replace the x squared with sine squared x. And we can do the same thing for y. We can replace y with cosine squared x. And that will give us the original equation, sine squared x plus cosine squared x equals to 1. And now let's move on to proving that tan x equals to sine x by cosine x. By now we know that sine x equals to opposite divided by hypotenuse, and cosine x equals to adjacent divided by hypotenuse. So that means we can replace sine x with opposite divided by hypotenuse and cosine x with adjacent divided by hypotenuse. So sine x cosine x equals to opposite by hypotenuse divided by, yes, this is a complex fraction, divided by adjacent by hypotenuse. Or we could write like this: opposite by hypotenuse times hypotenuse by adjacent. And as you can see, both hypotenuse cancels out and we will remain with opposite by adjacent. We know that tan x equals to opposite divided by adjacent. That's why it's going to be equal to tan x. So we've proven that tan x equals to sine x by cosine x. Alright, so you can also prove cotan equals to cosine x by sine x through the same process, only the terms will be a bit different. Well, only the terms will be the other way around, and that's it. Anyways, let's move on to another identity. So the other identity is secant x equals to 1 by cosine x. So we know that secant x equals to a hypotenuse. You know what? We know that secant x equals to hypotenuse divided by adjacent, and for cosine it is adjacent divided by hypotenuse. So now we can rewrite the forms here. That is hypotenuse divided by adjacent equals to 1 by adjacent by hypotenuse. So we want both sides to be the same. So the next step is to write the other form of adjacent by hypotenuse. In here it is 1 divided by adjacent and hypotenuse. And if you flip it, if you divide it, it will be flipped. So yeah, let's write that. Hypotenuse divided by adjacent equals to 1 times hypotenuse by adjacent, which is equal to hypotenuse by adjacent, and hence we've proven that secant x equals to 1 by cosine x. Alright, now let's do this identity, which is 1 plus tan squared x equals to secant squared x. So we know that tan squared x tan squared x equals to sine squared x by cosine squared x, uh, and secant squared x wait, secant squared x equals to 1 by cosine squared x. So now let's input these values in the equation. 1 plus sine squared x by cosine squared x equals to 1 by cosine squared x. So now let's combine the two terms on the left side by matching the denominator, which will be like this, or cosine squared x cosine squared x plus sine squared squared x equals to 1 by cosine squared x. Wait. Cosine squared x. So now remember the theorem, the sine squared x plus cosine squared x equals to 1. Yeah, we can apply that in here, which will be 1 by cosine squared x equals to 1 by cosine squared x. And hence we have proven that 1 plus tan squared x equals to secant squared x. Now let's do this equation, let's prove this equation, that is cosine a minus a equals to 1. So how can you prove this? First, know that another theorem we have to know that, which is cosine a minus b equals to cos a cos b plus, yes it is plus, sine a sine b. Now since both variables are equal, we could also write cos a minus a as like this. Cos a plus sine a sine a. Or we could write cos a squared, cos squared a plus sine squared a. And this is also equal to 1. And another way to do this is knowing that cos a minus a, or any variable subtracted by itself, will be 0, and cos 0 is always equal to 1. So here is our answer, and we've proven this equation. All right, try this identity. Cos 2x, cos 2x equals to 1 minus sine squared x. Okay, 2 sine squared x. Now we know that cosine 2x equals to cos squared x minus sine squared x. From sine squared plus cosine squared x equals to 1. We know that if you move sine squared x to the other side, it will be cosine squared x equals to 1 minus sine squared x. That means cosine squared x will be equal to 1 minus sine squared x. We can apply that formula in our equation, or cosine 2x equals to 1 minus sine squared x minus sine squared x. Since both minus sine squared x and sine squared x negative, it can also be written as 1 minus 2 1 minus 2 sine squared x, and hence we have proven that cosine 2x equals to 1 minus 2 sine squared x. Alright, so the next identity is proving that sine 2x equals to 2 sine x. cosine x. So how can we start? Let's start with angle addition formula that states sine a plus b equals to sine a, sorry, sine a cos b plus cos a sine b. Now let a and b equals to x. Therefore, the equation will be sine x plus x equals to sine x cos x plus cos x sine x. Now we can simplify it to sine 2x. Now we know that we have sine x cos x plus cos x sine x. Since both of them are basically the same, we can write it as 2 sine x cosine x because we're adding up two of the same number together, actually not the same number, same value together, so it will be 2 times sine x cos x. Finally, the last identity I want to give for this episode is tan 2x equals to 2 tan x by 1 minus tan squared x. So we know that tan x equals to sine x by cosine x, sine x by cosine x. We also know that sine 2x equals to 2 sine x by cosine x, equals to 2 sine x cosine x. And cos 2x equals to cosine squared x minus sine squared x. So that means you can write this as tan 2x equals to sine 2x by cosine 2x, or tan 2x equals to 2 sine x cosine x by cos squared x minus sine squared x. Now for sine tan x equals to sine x by cosine x, we can derive that sine x equals to tan x cosine x. So let's apply the formula in this equation. 2 tan x by cosine x times cosine x divided by cosine squared x minus tan squared x cosine squared x. Now let's simplify the expression as as 10 sorry 2 tan x cos x by cos squared x minus tan squared x cosine squared x. This is going to be cos squared x actually. My bad. So now we can factor out cos squared x in the denominator, which is 2 tan cos squared x 2 tan x by cos squared x 1 minus tan squared x, and then these will cancel out cos squared x, which shall give the final answer as 2 tan x by 1 minus tan squared x, and hence we have proven the equation tan 2x. So thank you so much for watching. Please consider liking and subscribing my channel and hit the notification bell so that you'll never miss these types of content. And I'll produce more of these math problems and solutions in the future.